Guys, welcome back. I hope you're all doing great. We have to discuss a couple of things together today, and it will take us a couple of minutes to do so, because we will talk about the three most important components of a computer that are important for us to run our sessions smooth and safe today, tomorrow, and in the future. And these are the very basics and essentials for us to know. Are you ready? Let's begin. Didn't work. Just forgot to say, make yourself comfortable. Okay, so the first one is the CPU, Central Processing Unit, the long version. Well, it's basically the brain of the entire computer. So every task you give the computer to do, it solves the problem or the task for you. There are many CPUs out there, literally thousands, and somehow we need to recognize or decide which CPU is better, which one is a bit better or better than the better one. I think you get it. There are certain parameters we need to discuss, and therefore I want to give you a real world example. So we do it not only theoretically, but practically as well, because this is more important. Now, there are two big companies that build CPUs for us, and the one is Intel and the other one is AMD. I don't want to discuss what is better. Again, it's just your own preference or your preference in the future. Whatever you use, it really doesn't matter for me and for others. Use whatever works for you, what you like, what you love, because the discussion, what is better, what is stronger, it's just just over the top, and it's about music. As I said in my first video, it's not about the techniques, it's about what's in your brain, in your heart, in your fingers and your ears. So everything else really doesn't matter. All the technology, it's great, but it's not the master. The master is you.
Remember that.
The first thing you need to know is that every single CPU is built of cores.
Ladies and gentlemen, the CPU decides how to spread the tasks among the cores, so it doesn't happen that one core is overloaded and the other one is underloaded.
The most common cores or processors are dual cores, so dual means 2 cores, or quad cores, quad core mean 4 cores. So my CPU is the i7 7700K 4.2 gigahertz from Intel. Good, now let's talk about the factors that are important for us to know how
high
the performance actually of the specific CPU is. So the first one is the letter and the number i7. This one tells you how high the performance in general is. However, every other number is obviously important to know which specific model the CPU is. You need to know that there are i3 CPUs out there, i5, i7 and i9s. There are many more, but today, or the most common, are the i3, 5, 7 and 9s. The first thing to know is actually that the higher the number, the better the performance. The next number, the 7 in our case, is the generation it was built in. So for every generation, in this case Intel has a lake. So if you Google the lake, you know what the next generation will be from Intel, I guess. So in this case, the 7 stands for Kaby Lake. Cool, the next one is the 700, and the 700 is basically the model number of the CPU, and it tells you again how powerful the CPU is. So if you have the same CPU, i7 7600, it will be lower in performance as the one I have. The letter behind the model number tells you for what specific task the CPU was built in. In this case, K is standing for overclocking. I will tell you in a couple of seconds what this is. T is, for example, is standing for energy efficiency. So there are many different options how a CPU could be built. So Intel in this case is putting numbers behind the model number, letters behind the model numbers to tell you for what specific task the CPU is built for. Cool, the next one, 4.2 gigahertz, is the clock rate. So how fast the CPU is actually running during the working hours. And well, there are many different gigahertz options. Therefore, again, the higher the number, the higher the performance. Yeah, and the last thing which I have mentioned before, overclocking, is nothing else than
turbo boost.
Sometimes you find the name overclocking, sometimes you will find the name turbo boost, and it's if the option is there. So in my case, my CPU has the letter K behind the model number. So K is standing that the CPU is capable of overclocking the usual clock rate, in this case 4.2. And then I will find a second gigahertz number, sorry, that will tell me how far it will go for really the maximum. Why overclocking? In some cases, like when we are printing the DAW session or working with rendering a movie file, as I'm doing it basically not daily but weekly. So the process is really hard for the CPU because many different tasks have to go through the process. So in this case, if the CPU decides, hey, I need a little bit more power, I can do this by overclocking the usual clock rate. That's simple. Got it? Cool. As I said before, there are really a lot of CPUs out there. If you want to check your CPU out, Google it, and why you should do this actually. No, what I wanted to say is that there is a site that is called cpubenchmark.net. You can find every CPU which is listed there, not every, but a lot. And you can actually check how good your own CPU, if it's in the list, is performing compared to the others which are in the market. So you will find a number behind your CPU, let's say 10,000 points. It's usually like, I say it's points, but it's just a number. So the higher the number, again, the better the CPU in overall performance will be.
Any questions so far? Good. Then leave them in the comments box down below.
Cool. Now let's talk about RAM, random access memory. What does it mean? Before I will tell you what that means, I want to ask you, have you ever experienced that at some point your computer just started to be extremely slow and you wondered why it happened or it happens? It's because of your RAM in most cases. Well, every time when you open an application, start to work in the application, you load every time specific data and information. And if you go to the internet as well, you load up many different tabs. You Google something, you Google on the other side something. So it adds up, and you want to have extremely fast recall times for that information. So, this is why RAM is built, especially in these cases, because the connection is called PCI, and basically this is the data transfer through PCI is much faster than your hard drive can actually access. So your hard drive is run in most cases through SATA 3, SATA 3, and PCI is responsible for your RAM. So your RAM sticks, I don't have anything in my hand, but the RAM sticks are, as I said, just for the case that because you want to recall the information extremely fast, it's possible because the connection speeds allow to have instant access. For your hard drives, no matter what hard drive you have, it's not possible because the speed is much slower. Now the problem with RAM is when you switch off the computer and everything what you have stored or preloaded into the RAM, it will be erased. So when you launch again, so you start your computer again, you need to start the process over again. So when you switch on the computer and try to recall, it's erased. So you need to again Google the sites you have been Googling and all the other applications as well. So RAM is not permanent. It's erased every time you switch off your computer. Cool, and now let's talk about some numbers, because numbers are important, so we have something practical to see, and we just know how it really works in the real world. Because nobody cares how it theoretically works, we just need to see the result. And the result is actually, I had for many years a laptop I showed in my first video. Well, I can say this. It was a MacBook from 2011, and at that time I had 8 gigabytes of RAM. Now the problem is that, I don't know if you know, but I had no idea that it was true, but it was true. So when I launched the Mac, so when I switched on the Mac, there are a couple of applications that are out there to show you how much actually RAM you have access to. I think one is called Memory Clean, something like that. You can Google yourself. It just basically shows you how much RAM is used and how much is left for usage. I have something in my eye. Yeah, so when I switched off my Mac, I had only 6.5 left, and I wondered. So the thing is that your system uses RAM as well to run the applications, the system, not the application, the system. I have something in my eyes again. So your system already uses a couple of gigabytes from your RAM storage. So I think it depends on the system as well. So if you use Windows, you use Mac OS, it depends as well how much RAM you actually have. So this was my experience. I had 8 at that time, and when I launched the computer, I had basically 1.5 gone. So 6.5 were left. Now, the thing is that for every application you use, the application uses some megabytes, or in this case, Logic. I worked with Logic. It used 2 gigabytes to work with. And so the thing is that if you take away from 8 1.5 and then 2 again, you have 4.5 left to work. In the practical world, it's not a lot. Look, if you have 4.5, or I had 4.5 left, it means really if I have 8 instruments or 9 instruments that have more than half a gigabyte of preloaded RAM samples, so I had only 9 instruments to work with. And then what happens is what I described in the beginning with an answer. Have you ever experienced yourself that your computer just freezes and you have no idea what's going on? This is exactly the point where the whole storage of your RAM is used. Everything is used. And at that point, your computer can't handle the usual tasks anymore because the storage is over. Now, there is a question that is often asked: how should I work actually if I have only 8 gigabytes of RAM, and this is constantly happening to me? Now, the thing is, as I said, I worked for many years like this, and I had sessions that were 80 plus tracks in size. And what I did is I printed the tracks I finished actually arranging to audio files. So what happens is that you can purge your RAM, so get rid of every sample you actually preloaded that is now an audio file. So you freed up your RAM and can actually use more samples, so the other patches which you actually want to use. Now the problem is, when you want to rearrange the part, you need to go back to the MIDI file, and so you need to again load the samples back in. So it's frustrating and it sucks. And then you ask, obviously, how much RAM should I get to, to have the option to have more MIDI tracks at the same time without every time bouncing them into audio tracks. Now let me give you a recommendation, because I think there are three options how you should think about RAM. And the first one is obviously if you use a lot of applications at the same time, like me. So I'm recording right now the video, I'm using the application for the camera, I'm using the application, so the DAW, to record the voice. For this video, I use Keynote as my PowerPoint presentation. So I have basically an overview. What should I tell you at the very moment? And some internet tabs are open as well, so I can type in a word. I have no idea how it is pronounced in English, or how the word is actually in English, which I have in my hand, in my head.
You see, I'm learning in English all the time.
So many applications are open, so I need a lot of RAM. And it's usually, if you work like this, you already need to think about going from 8 to 16. So I think for this scenario, 16 is enough. Now the second scenario is if you use a lot of sample libraries. So you work with a lot of sample libraries that are super big. So I'm talking about libraries like Spitfire libraries or Cinesamples, or all the orchestral possible native instruments, bundles, and whatever. They use a lot of RAM. So I believe that 16 is not enough, because it's not enough. Because the sessions are getting bigger and bigger with the time you invest in learning composition, and you start to add tracks, you start to layer the tracks, and you don't want to print them every time in audio files, so you just need the storage. And 16, I think, if you're doing cinematic music and trailer, or you want to do this, go beyond that. Try to get 32 or 64 if you have the money and the option. The option, I will tell you in a bit what the option is. No, I will tell you right now. The thing is that not every CPU can handle the RAM you actually can buy. So the thing is that if you have, it's just a general rule, if you have a dual core, it goes up to 16. If you have quad core, it goes up to 64. And if you have 6, 8 or a better CPU, you can go up to 128 or even higher. Even if you have the money, if you have, I don't know, 700 bucks to buy 128 gigabytes of RAM, but you have only a dual core processor with 2 cores, there is no way that you can put 128 inside and they will be recognized as 128. So what you need to do first before upgrading, if you decide to upgrade, you need to check out your CPU, how much maximum RAM can be accepted by the CPU. If you see that you can only have 32, but 32 is not enough, the only thing you can do is only upgrading first your CPU, getting a better CPU, and then going, of course, for the RAM. The third option is if you only mix and master. If you only mix and master, there is absolutely no reason why you should upgrade to 16, 32, 128. Why? Because you don't use many applications. At the same time, you don't use sample libraries that are preloaded into your RAM, right? So there's really absolutely no reason to invest the money, actually waste the money. Your computer will not be better because you have more RAM. The RAM is only important to run many applications at the same time and to run many MIDI tracks, instrument tracks at the same time. So if you only mix and master, it's better to invest in a better CPU and a better, faster hard drive, period.
Got it? Cool.
And now let's talk about the third component, which everybody knows, and it's extremely important because I have actually a story to tell after at the end. Hard drives or hard drive, HDD and SSD. Well, these are the most common which we use today. However, I think in the future we will see a switch to the faster connection I told you before, which is called PCI or PCI Express. Let's talk about HDD, SSD advantages and disadvantages. The HDD is bigger. We have 2.5 and 3.5 inch. Obviously, because it's bigger, it's heavier. HDD is slower compared to the SSD. Why? Because it's built of physical components, of moving components. It acts like a disk with a reading head. So it has to move, to spin, and therefore it needs some time to recognize where is your information, how to get faster access, and obviously because it's moving, it takes some time. Because it's moving, it's louder. Now, one of the advantages is that you can have more storage, so you can buy more storage in general. Another advantage is that HDD compared to SSD are cheaper, much cheaper. And the last one, I put it down in brackets, it's safer. The thing is, if the drive fails, there is still an option to rescue the files with a technician who is working, on restoring the files. So it's not 100%, but the option is there. Now let's talk about SSD. SSD are obviously smaller. There is a 2.5 inch option, and you have PCI already there. Smaller means lighter as well. SSDs are much faster. In general, almost 3 times the speed of HDD. Why? Because there are no moving parts anywhere. It's based on flash storage. So like your SD card for your camera, something like that. So the access times are 3 times, in general, 3 times faster than on HDD. Obviously, because the parts are not moving there, the SSD is silent, no sound. A disadvantage is less storage options. I think it's not exactly true because, as I said, there are already SSDs which are extremely large. The biggest one I searched was a Samsung, I guess. It was 16 terabytes, but I said it's extremely expensive. This is one still big disadvantage of SSDs. They're extremely expensive. And the last one, obviously, if it fails, breaks or falls apart, which shouldn't be the case if it falls down, but if it fails, just, one of the components fails, then there is no option to restore your information, your data. So
game over.
So no matter what drive you use, always back up your system. You never know. You never know. Good? Good. Now there is a question which is often asked: what drive should I actually use for my work? The best way, because you already know that SSD is much faster, I would say that, and I think the transition always happened, that in most cases the system drives are already the fastest ones, so the SSDs. So you can have extremely fast access to your whole system, so to your applications, and this is basically the main thing, that your system is running on the faster drive. Now the thing is that SSDs, as I said before, are extremely expensive. If you know that you have 2 or 3 terabytes of storage for your sample libraries, for example, so I think it makes sense to invest in a bigger SSD. Why? Because the the samples which are loaded into your RAM from your SSD, the process will take you definitely less time, at least 3 times the speed of HDD. So you don't waste a lot of time when launching a new project. Now, if you have more than, let's say, 4 terabyte, you need the money, obviously, because I mean, right now, as you see, 4 terabytes are around 500 euros. So 8 will be around 1,000 euros. It's a lot of money. It's your decision, but I think a good option is really to go for the faster HDD compared to the slower HDD, because there are 2 versions, which I didn't mention before. The slowest one is the 5400, and the faster one is the 7200. It means that 5400 rotations per minute. So the drive rotates 5400 times per minute, and the bigger one 7200 times per minute. The difference between the speed of the slower and the faster one is around 150 bits per second. You need to divide this value by 8 to get the bytes numbers. However, I will talk about the binary number system right now, because I think it's important to know actually how much storage you really need in order to have a more, let's say, successful studio life in the future, because the projects, add up during the whole year. I will make an example, as I said. So we see actually the numbers in a practical way. So I think that there are not many people as well who clean up their drives. So the storage, gets less. And at some point you're like running out of space, and I need to invest in a new drive. So that's why I want to talk about the numbers game as well. So let's talk about the binary system, how it works, and let's check the numbers.
The binary number system. Remember that a bit is the smallest unit of data described and used by the computer language.
A bit has always a value of either a 1 or a 0, and 1 byte are 8 bits. Now, when we talk about storage, we always refer to bytes. When we talk about data transfer, so transferring a file from one drive to another, we talk about bits. For example, the SSD, the maximum speed it can achieve with SATA 3, it's 550 megabits per second. We need to divide it by the number of 8, because 1 byte is 8 bits, so we divide 550 by 8 and we get roughly 70 megabytes per second. Okay, cool. I think this one I don't need to explain, it explains itself. So basically we see here how many kilobytes are bytes, how many terabytes are gigabytes, etc. Now let's do basic elementary school mathematics so we know how much storage we actually need. So CD quality is 44.1 kilohertz with 16-bit recording. We take this as an example. So what we want to figure out, how much storage 1 minute has of this quality. As we know, 8 bits are 1 byte, 16 bits are 2 bytes. So now what we need to do is transfer the bits into bytes. So 16 bits we transfer to 2 bytes. When we multiply these two numbers, so the 44 with 2 bytes, we get 88,200 bytes. Now, in order to know how many kilobytes these 88,000 are, we need to divide the number by 1024, right? Now, when we do this, we have 86 kilobytes, it doesn't matter. And now what we do is we need to multiply it by 60 because 1 minute has 60 seconds and we get roughly 5 megabytes per channel per minute. One channel, so mono. So if you want to have 2 channels, left and right, stereo, we need to multiply by exactly 2. The next one is an example for 48 kilohertz 16-bit. Because when we work with video files, so when we sync audio to video, we usually work with 48 kilohertz. So we get roughly 11 megabytes per minute for a stereo file. There are many people who like to record an even higher rate. So if you go for 96 kilohertz and you want to record in 24-bit, which usually we do, it means that at the end we have for only one channel for 1 hour recording, we have roughly 1 gigabyte of storage needed. So if you're a drummer or you want to record a drummer and you have 10 drum mics, because we have 2 for the bass drum, 2 for the snare, 1 for the hi-hat, we have already 5, 3 for the toms, we have 8, then we have a pair of stereo, like for example, a small AB or how do you call it, XY position. And we have a room mic, so we have 10 or 11 mics. So you can, if you record in 96 24-bit, you have for 1 hour for all these channels, you have 10 or 11 gigabytes in total. I think these numbers are important as far to know that you know how the calculation is done, because sometimes someone asks you, hey, I just want that you record my next concert, and then you ask, okay, how many instruments do you have, how many channels? And the guy says, well, we have 24 channels and we use, let's say, 22 of them. And you're okay, and how long is the concert? And you say like about 2 hours. So now you can, for yourself, look how much actually storage you need. So is your 120 gigabyte external hard drive enough to record or not?
But do the calculation yourself.
Now when we do the whole calculation for the week and for the month, as you see, we can easily get to a number that will be around 100 gigabytes per month if your projects are more or less stable, and you go for the highest possible recording quality every single time. And if you work with sample libraries as well, it really adds up. So one project is around 4 gigabyte, the next will be 15. I had one project, it had 25. And the thing is, not everybody is erasing all the files which are not necessary. So just check actually how much storage you have and get rid of the unnecessary files. It's really simple. You just need to delete them. You need to have some sort of structure and order. Otherwise, you will reach amounts that will basically kill your hard drive and your money as well. Because as you see, in 1 month, we can easily go to 100 gigabytes almost. And if we add up and multiply it by 12, for the next year, you will be more than 1 terabyte in project files. So if you add up for, for the next 2-3 years, you will have already one drive that is that big from only your projects. And if you start to work with other applications and videos, etc., and footage and whatever is actually possible in today's world, you will much faster exceed these numbers. So this is just an example of regular projects that actually many of us already have. And I said it's not only one project that is composing. It can be a recording somewhere, and the one project can be a little bit smaller. The other one is bigger. I just made a real world example because I know how big my files are and how much storage I have. So again, as a general rule, I would say, to summarize the hard drive thing, that you need to have definitely for your system a fast drive, so an SSD in the best way, in the best option. For your sample libraries, if you have the money, invest in definitely one drive. I think it's a good investment because you will have definitely just a better time overall in your work process to to restore the samples to your RAM. I think that for just overall storage, you don't need a faster HDD. I work, for example, right now with a 720, 7200. All my samples are there. It's definitely okay. It works. It's definitely better than the slower HDD. I feel the speed really. The projects are opening much faster. However, again, if I have a lot of projects, I see myself that I need to go to an SSD at least for my sample libraries and invest the money. It's not cheap, as I said, you see the prices. It's still expensive, but if you really want to have a better studio time and just don't want to waste another 20 minutes to open your project files from your slow HDD, then I think it's definitely a good option for the future. And now let's go to the last topic I would like to talk about is backup. And I said it already somewhere in the middle of the video. Definitely backup everything you do, every single day, every single project. Why? Because it will save your life. And I will tell you a true story, which thankfully didn't happen to me, but it happened to another guy who told me the story. And I laughed, but I think many people who were involved in this project, they cried because it was extremely sad at the end. So the guy invited a band from Austria to Hamburg, and the whole band flew to Hamburg to record a studio album for 3 days. So they worked for 3 days in the studio to record the whole thing, and they recorded everything, and they had a flight back to Austria. And unfortunately, on the other side of the street, there was a construction site. And again, unfortunately, a digger hit the electricity circuit And every single building what was around the whole construction site had electrical failure in the system, and the guy didn't back up the drive, and the drive, so the whole computer and the drive, they failed. You know what happened? He lost all the files and it was impossible to restore everything. So it was an extremely sad moment, I think, for not only him, but telling the band that they wasted really 3 days, hard work, 12, 14 hours a day. I believe that much time you need definitely in the studio to have something great as an outcome, and everything was away as it was never recorded ever. So definitely invest in a second drive, at least in a second drive, so you can back up everything you do. And remember, it can happen to you as well. And, when I started, I thought the same, like, I'm working, everything is working, the computer is working, the drive is working, what should happen? And, before it happens, everything is fine. But if it happens, and it happens sometimes, you will go crazy because, as I said, you will lose the time, you will lose money, you will lose your temper, you will lose basically everything what is surrounded this incidents, and you really will blame yourself because you were stupid enough to rely on the technical part. And I think it's a really great rule, or how do you call it, like a rule of thumb, that definitely have something as a backup in your studio or at your home. However, if you have the possibility, invest a little bit more money to have it somewhere as a cloud backup as well online. I use, for example, it's called
Backblaze.
And I pay basically for online storage, and it's a great option because I know that my files are somewhere in the cloud in another physical place, So even if my home is burning, I still have all my work somewhere in another place in the world. This is extremely important to think this way, because it makes you professional. And it doesn't really matter if you're earning money with music or with audio, it just makes you professional in your mind, and it shows yourself, not everybody else. It just shows yourself that you're really professional about your work and you're serious about what you're doing. So please, if you have the opportunity, invest the 10 euros it will cost you a month. I'm not sure how the prices are right now, but it costs a little bit of money. But I think that in the worst case, the money you invest actually in having this option, it will be much, much cheaper than what I described in the story, that a whole band with hotel, with the with the flight and everything what is surrounded with eating and blah blah blah, studio time, it just costs a lot of money and work, and you don't want to lose it. You want to be safe, and the only thing you can be safe is when you invest a little bit more money into your backup drive and cloud storage. So again, if you're serious about what you're doing, invest the money, because you don't need extra plugins, you don't need extra sample libraries if you don't have the option to have your work, what you did a day ago or a year ago, somewhere else in the world. You want to spread the odds that if it fails, that you're still safe, because it's somewhere in another place, still waiting for you to have access again. Because the thing is, you can always buy the next drive, you can always buy your next computer, you can always buy your next sample library, you can always buy everything what is physical, but you can't buy your time and your effort you put in again. And this is critical to understand, so please do it. Please do it. Guys, I think it's over. It took us a little bit of time. I know it was maybe in some parts boring because we had dealt with theory, and we didn't cover what we are doing, the art. But the thing is, it's really critical to understand the basics, to know how they function, because now we can concentrate on the really important part, the art. If you understand the physics behind it, it will be much easier to understand the whole process, because it will be easier for you in the future to decide what you actually need and what you don't need. And as I said, I just can give my own recommendation to you, but you still need to decide for yourself what is important for you and what is not important for you as well. So thank you for staying with me until the end. I have no idea how many minutes it took me to tell you all of this. However, I think the most important thing is at the end the story, that you need to take responsibility for your work and your time and the time of others. This is really the most important thing. It doesn't matter how great your computer is, how great your sample libraries are, how great your plugins are. It doesn't count at all. Only what counts is really your time, effort, and your responsibility to save everything what you worked on in the past. Again, if you liked what I shared with you today, please share, subscribe, and like, and tell your friends to come to this channel, support. If you have something to add I have missed, maybe I have missed, I have no idea, I think I have missed something. So please write down in the comments box down below, so every other music and audio enthusiast can check this out, and so we can have this conversation. Again, thank you so much for being with me until the end. Have a great day, take care of yourself, and be amazing. See you in the next video, guys. Bye.